Alright, hello, my name is Connor Burke and I'll be giving a demo and overview of Summersong, which is a data analytics platform I'm developing. This is version 0 of the platform. Okay, I'll give some general info and go over the components of the system. I'll then dive a little deeper into the technical overview and technologies used. I'll show the workflow of information in Summersong and I'll give a brief demo. Then I'll wrap up with future upgrades planned for the platform. So general info, Summersong is a platform that enables users to upload data sets. So they can upload CSV files that have numeric info, and then a data model will be generated that allows them to query that data model with new data points they have, which generates a prediction for a certain parameter. The name Summersong comes from the book Neuromancer, where there was an AI agent in that book named Wintermute, which used humans for nefarious purposes. So I came up with the name Summersong as an antonym to that, which is just seeking to be helpful to humans. Okay, the components of Summersong. There's a REST API, which is known as the tone service, and this accepts file uploads and also the query request. Right now it's the entry point for the platform for the clients. There's also the harmonizer service, which builds the data models, and then the melody service, which queries the data models. There's also Redis, Kafka, and AWS, and those are used for caching, message brokering, and there's several AWS components for storage, notifications, and authorization as well. Okay, technical overview. So for version 0, as I mentioned, Summersong accepts CSV files with numeric data, and those are sent to the tone service, which processes them, stores them in AWS, and then triggers the harmonizer service to build the data model. And those data models in Summersong are known as harmonizers. Once a data model is built, the user can then query that data model, again going through the tone service, but then the message will be passed to the melody service, which queries the data model with the new data points and returns some output to the user with what it thinks the prediction is. So technologies used, the tone service, which is the REST API, is built with Java and Spring Boot. The harmonizer and melody service use Python, and the data models right now are decision trees that are implemented as NumPy arrays. You might wonder why I use Java for the tone service instead of using something like Django and sticking with Python, and that's because Python's really good at data science tasks, but I would prefer to use a statically typed compiled language for general web services when possible, and that's why I use Spring Boot. Kafka is used as the message broker between the services. Redis is used for caching, so the harmonizers, once built, the Melody service will look them up in a Redis cache before trying to go over the net to AWS. And AWS is where most of the other services live. We use Cognito for authentication, S3 and DynamoDB for storage, and then Lambda and SNS are used for user notifications. The application is containerized with Docker, and it gets used for version control, and then I set up some GitHub actions for continuous integration and testing. So here's the overall flow of the different components of Summersong and how information is transferred through them. There's 4 general areas or general flows of information. So flow 1 just deals with authentication. Basically, the client needs to authenticate with Cognito, and then the tone service will verify that token when it receives a request. Flow 2 is when a user creates a data model. So they would upload a CSV file with the data that they want to use to create the data model. The tone service accepts that, stores it in an S3 bucket, and lets the harmonizer service know about it, decoupled through Kafka. When the harmonizer service receives a message that a new harmonizer needs to be built, it'll pull that down from the S3 bucket, and then it will build a series of decision trees and store that object in another bucket with associated metadata in DynamoDB. Once that's done, the user's then able to query the data model. So they would send a new file with data points that they want some kind of answer or prediction for. That message gets sent to Kafka, and the Melody service subscribes to that topic. When it receives that message, it will do two things. It'll pull down the harmonizer that was built earlier, unless it's cached in Redis, and it'll also pull down the data points to be queried, which the tone service uploaded to another S3 bucket. Once it has those, it'll run the data points through the data model and come up with some sort of prediction. That prediction gets stored in DynamoDB, which is pulled by a Lambda function, and when the Lambda function sees that a new insert in DynamoDB has been created, it will trigger SNS to send a notification to the user, which right now is in the form of email. So a quick demo. My client for this will be Postman. So here is, we'll be sending a file to Tones to build a harmonizer. Here we have the authorization token, which I already got from Cognito. And here's the body, which is a CSV file, just to give you an idea of what that looks like. Here's the CSV file that we'll be using to build the data model. And then we'll be querying it with this file, which is the same points but does not have this last column, which is what we'll be trying to predict. So we'll go ahead and upload this file. Taking 1 second. Okay, so see, the tone service has received the file. It's storing it in S3. And sent a message to Kafka, and then the harmonizer service picked that message up, and here is the decision model that it built. We can see in S3, if we refresh our objects here, our most recent object built was this 68F, which is this object right here. And then additionally, so that's the actual CSV file the user uploaded. And then in the harmonizer bucket, we see this file. Now, it has the same file name, but this is actually the serialized Python object that's stored as a result of the harmonizer building those decision trees. So now that we have a data model built, we can query it. So I'm going to take the name of this harmonizer, include that in the post here, and we'll send that off. And we can see, so Tones is accepting a query request at this point, and it's uploading that file to another S3 bucket, generating the Kafka message, and then we can see the melodic service here picked it up, and it ran the query, and it says it's not in cache, so it had to go to S3 to pull it down. And that just completed. If we go over to this is the melodies table in DynamoDB. This will have the output for the query that was just run. So let's refresh those. And this is the output. So its first prediction for that first data point is 0.0265, and the actual value was 0.0285. So relatively close. Seems to be doing a decent prediction job. And if we go here, here's the notification that we just received via Lambda and SNS. And this has those same data points. This is actually, let's change this, was not the most recent one. Here we go, 0.0224. And we come back to here. 0.0224. Okay, so that's the most recent prediction. I'd run this earlier to test it. And as you can see, the value for that data model was just slightly different because it's using random decision trees. Okay, so that's the demo for Summersong. I'll give some upgrades I have in mind for the platform. So for version 1, a lot of this revolves around really solidifying the platform with more CI, CD, and testing. And I also wanted to be able to accept additional files other than CSV. So I'm looking at SQL, JSON, and XML specifically. In addition to being able to do regression analysis. I want it to be able to do classification for other types of data sets. And then for version 2, the grand plan for Summersong is to be able to automate all these kinds of predictions. So a user could upload data initially to build a data model, and then from there on, whenever new transactions are added to a database, Summersong could be automatically triggered to run a query on that, so that the user would be giving a prediction for the data points inputted. So like for an example, if a company is curious about how long it'll take for an order to be processed, they could use prior data points such as the type of order, when it was processed, the materials on hand to process it, any kind of parameters they want. And then if they're interested in how long that order takes, Summersong could potentially give them some kind of prediction which would have business value for that client. Okay, so that's the current state of Summersong. Thanks for listening, and stay tuned for updates.